This Enigma project is going to be about linguistics and computational linguistics. Linguistics is a pretty fascinating field, and it's probably a bit different to the other projects that have been presented because the other projects have taken an existing field, such as literature or science, and grabbed a particular minor part of that field, a particular specific element, and honed in on that. And it's a field you already know quite a lot about, so we could hone in on that. Linguistics is a bit different because linguistics is an entire field. So it's a much bigger topic than the other topics that have been presented. But because you haven't really learnt about linguistics before, it's a bit hard to hone in too far because really, if you're going to do anything, you need to start by understanding the general principles of linguistics. That said, we will look at computational linguistics, which is a little bit of a specialisation, but not hugely. The presentation I'll be doing will talk both about linguistics and about computational linguistics. The difference is that the second one generally will also include skill as a programmer will assist with the second one, whereas if general linguistics doesn't require that. Linguistics then is the study of language, and it has quite a number of applications, a growing number of applications, not including things like natural language processing, which is the way that Google translates languages from one. Google translates communication from one language to another. Now I'm going to give you an example of a quite a fun sentence. So parse this, or parse means interpret, parse this as I write it. And try to pick when the sentence stops. And that's it. So I'll give you a second to look at that. If you're like me, and like most people, you're struggling to interpret that sentence. Specifically, the word fell probably surprised you. You probably thought it was due to end after the word barn. But that sentence is grammatically correct without the addition of any commas or anything like that. Let me give you another example of a similar sentence that maybe is easier to solve. The old man, the boat. Now, that one, probably you would first interpret that as the old man and then as the boat. But in fact, what that sentence is saying is that the boat is manned by old people. So when you see man as a verb, the old, well, what do? Well, they man the boat. And suddenly that sentence that you initially probably parsed as the old man, the boat, which is just two noun clauses, one after another, and doesn't make any sense. Now, by changing man to a verb, the sentence actually makes clear sense. And the same is true with the horse raced past the barn fell. So let's look at the horse race past the barn fell. Your initial analysis of it was probably went like this. You grabbed the horse, which is a noun clause. Then you said, well, what did the horse do? It raced past. That's the verb clause. And what did it race past? The barn. There's the noun clause. And then I said fell, and you said no thank you. However, the way you can parse that sentence is like this. The horse raced past the barn, fell. So what's going on here is a horse is falling over. Which horse is falling over? That horse there, the horse that happened to race past the barn just a moment ago, fell. Now, adding the word that would probably be standard if you were actually saying this sentence, but the fact is the horse raced past the barn is a particular horse. It's that horse over there. Just like the horse which is brown, or the horse Ed, meaning the horse named Ed, fell. All of those sentences would be correct. So this is what's called a garden path sentence, where when you've only seen part of the sentence, let's say up to here, it seems that you're processing it correctly grammar-wise. You read the horse, race past, oh, this is clear, I've worked out the grammar of this sentence, and your brain is ticking along, assuming that the next thing it's going to hear is a noun. And that's because our brain automatically processes the grammar of what we're reading. Now, sometimes it's ambiguous as to how the grammar can form, and our brain's really good. It can kind of process multiple possible grammars at the same time, but it can't go too far. The real trick, the reason that the horse raced past the barn so hard, is that you only identify your error when you get to the word fell, but the error had occurred all the way back here. That was the moment where we made the mistake, and that was 4 words ago. By then we've moved on, we've processed the word raced as a verb, we're done with that, and it's not until we have to realise that that verb is actually part of the noun. It's not the main verb in the sentence. Fell is the main verb in the sentence. We can do the same with the old man, the boat. So your initial parsing was the old man, and then you saw, okay, we've got an old man, and then the boat, and that didn't make sense. But the correct parsing is the old, and then the word man has to be treated as a verb. So the old is your noun clause, man is your verb, and then the boat is your noun. And that will make sense, but the other way it doesn't. So we can use a language called BNF, which stands for like be something nays form. So I think it was made by 2 people with bets and nays or something like that. We can define a grammar for English. So here I've made some BNF to define some basic English grammar. As you look at that, you can see a few things. So here, a sentence has to have a noun clause, then a verb clause, then a noun clause. And it just so happens that we're going to keep our verb clauses simple. We're just going to make a verb clause can only be a verb. So in our grammar, we actually couldn't say things like raced past the barn, because raced past the barn is a giant verb clause. We will, however, expand what our noun clauses can be. So currently, a noun clause can either be an article followed by a noun, or it can just be a noun. And we've defined what an article is here too, so we just use the or a. Let me show you an example of a couple of sentences that fit that grammar. The cat eats food is one example. Here, the cat combines to be a noun clause. Oops, sorry. Use the line. So here what happens is the cat, the is an article, cat is a noun, eats is a verb, and food is a noun. So the and cat combine here to become a noun clause, eats is a verb clause, and food is a noun clause. And therefore the whole sentence together makes sense. Another example is the cat eats the food. Here, the cat is a noun clause, eats is a verb clause, and the food is a noun clause. And those 3 combine together to make a sentence. And that's pretty much all we can do with this grammar. We can make nonsensical phrases like gravity rides the seat. Actually, that kind of makes sense. But There are lots of you can kind of grab any noun at all you want, any verb at all you want, any other noun at all you want, and it works. So you could say the gravity, and that is grammatically correct according to this grammar, even though we can't have the gravity, it fits the grammar. So semantics is where you need to come in and say, well, which of these things actually mean something? And that's kind of the next step after grammar. But let's improve our grammar. So what I've done here is I've expanded my noun clause to be, instead of an article then a noun, I've made it an article then a rich noun or a rich noun. And of course I've defined what a rich noun is. And a rich noun is either a plain noun or it could be an adjective followed by a noun. Now we can get a bit more sophisticated, such as the angry cat eats the mouse. Let's do this one. The mouse is our noun clause, that's the object. The angry cat, eats is our verb clause, and the angry cat is our other noun clause. Now let's examine how that works. So cat is a noun, angry is an adjective. An adjective and a noun forms a rich noun. The is our article, and an article and a rich noun forms a noun clause. And there's our sentence. So you can see that that is grammatically well formed. But there are some things we can't do in this grammar. So for example, we can't write the angry fat cat eats the mouse. And the problem with that lies in our grammar here. If you look at what a rich noun is, a rich noun can be an adjective followed by a noun, but it can't be two adjectives followed by a noun. So now, let's correct that. Here is another update to our BNF. This time what I've said is instead of a rich noun being an adjective followed then by a noun, or a plain noun, now a rich noun is an adjective followed by a rich noun, or a plain noun. Now this is recursion, and I know that a number of you have already learnt what recursion is. Those of you who haven't, recursion is the principle of self-reference. It's where a definition of something refers back to itself. An example of recursion is the Fibonacci sequence. You may know the Fibonacci sequence, which says that the nth term is the sum of the two previous terms. That is, it's impossible to define the Fibonacci sequence without referring back to terms in the Fibonacci sequence. And the Fibonacci sequence is therefore a recursive sequence, where to define the Fibonacci sequence you have to refer to its own definition. And this creates a bit of an interesting seeming paradox where you get this concept of, well, why isn't the definition going on to infinity? And the reason why it doesn't keep going and it doesn't keep referring to itself indefinitely is because we do have what's called a stopping case, and here is our stopping case. A rich noun can just be a noun. So basically, a rich noun can be any number of adjectives followed by a noun, because you can keep tacking adjective rich noun on as long as you want. Let me show you an example of what I mean. So here's the first part of a sentence. The full sentence is, the angry fat furry cat eats yummy chocolate mice. The first part of the sentence goes as follows. Cat is a noun, furry is an adjective followed by a noun. Oh, sorry, I left something out. This noun is also a rich noun, because a rich noun is allowed to just be a noun. So, a rich noun and an adjective is itself a rich noun. Fat is an adjective. Adjective and a rich noun is also a rich noun. And another adjective and another rich noun makes another rich noun. And eventually you have your article, which combines with a rich noun to make a noun clause. Quite a complex grammar tree, but once you make the grammar tree, we can analyse and see the structure of that particular sentence. Just give you another moment to look at that, and then I'll show you the rest of the sentence. So the rest of the sentence is, eats yummy chocolate mice. So this part's probably a bit easier. Mice is a noun, which is also a rich noun. Chocolate is an adjective. An adjective and a rich noun makes a rich noun. Well, chocolate doesn't have to be an adjective, but I'm using it as an adjective in this particular context. Yummy is an adjective. An adjective and a rich noun makes another rich noun. A noun clause can just be a rich noun. And then we get the rest of the sentence. So eats is your verb clause. We had the initial noun clause, which was, the fat cat, etc. So we say our first noun clause, eats, and then our yummy chocolate mice. One final thing to consider with English as a grammar is that it can be ambiguous. Each sentence I've given you so far can only be parsed in one way that makes semantic sense. However, sometimes you can write sentences which have multiple different interpretations, and it's actually completely ambiguous what the interpretation is because the grammar isn't clear. Now that's usually a context where we put in a comma, because a comma works in the same way that brackets do in maths. A comma kind of defines order of operations. In the context of language, it defines the order of, grammatical parsing priority, wherein you try not to create grammatical structures that cross the comma. The comma is like a separator saying, no, this is a stop point. It's a different grammatical structure on the right to the one on the left. And that's one of their purposes in English language, is to resolve ambiguities. I leave it as an exercise to you to think of how you might make an ambiguous sentence. But the hint I give you is that if you play with people and add suffixes to them, kind of like the horse raced past the barn, so you can say things like the girl the man knew is a very good way. If you chain another one of those on the end and play around a bit, you can get ambiguities where you don't know whether the big part of the grammar is hanging on the right, like it is here, with that big grammar complexity thing on the right, or whether it's a big grammar structure on the left, although in this case there isn't one. Now, while grammar in English is ambiguous, grammar in other contexts is fully defined. Here is a simple grammar for arithmetic expressions. So first up, an expression, which is your first thing, you can see is made up of terms or terms plus an expression. So a term is like x squared or 2x or 3. And you can have an expression can be a single term like 2x squared, or it could be 2x squared plus another expression, which might be 3y. Or it could be 3y plus 4z. So an expression is built up by essentially chaining a series of terms with a plus in between. And a term is defined similarly. A term is either one factor or chaining a number of factors together with times's in between. A factor is a constant or a variable, or it could indeed be anything at all in brackets. And that's where brackets fit. They let you make a factor which is more complicated, such as bracket 2 plus x, bracket times y. 2 plus x is now a giant factor. there are variables, there are constants, and there are digits. Now, what's the point in defining this grammar? Well, I mean, there's quite a few points. First of all, we teach order of operations in maths, and it's vital to teach it. We teach, do brackets first, do times next, do plus next, etc. But all of that is implied by this grammar. Because you create a tree structure, which therefore forces a tree structure. When I say a tree structure, I mean like on the previous slide, where I can draw verbs and link them all to be noun phrases and stuff. I can similarly parse or describe an arithmetic expression in that way. And that makes it unambiguous how I need to do the sum or do whatever the arithmetic is. You can make this grammar more complex. For instance, we haven't mentioned fractions and how they work. But the point here is that this is an unambiguous grammar, where there is only one correct way to interpret a sentence ever. So let's talk about applications of linguistics. And this is the final slide. First of all, as I said, linguistics is a big field, and the area of linguistics I know more about is computational linguistics. And that's because of my background as a computer programmer and as someone who did psychology, and I looked at the language aspects of psychology. Linguistics overlaps with an awful lot of other fields, and in particular it overlaps with the task that one of the other Enigma projects that has to do with language acquisition. In the computational linguistics field, you don't necessarily have to be able to computer program, but you either want to be able to do that or do some pretty decent mathematics. The kinds of things you can do is, first of all, you could write a solver to solve maths and chemistry equations, which is really quite fun. You could do a much better job than something like MathTrack does and Math Online, because you could, in theory, make something which can randomly produce expressions of specified complexity based on how big that, how much of the grammar you're using in one question, and your solver could also work out the value of those maths expressions by going through the grammar. Similarly, you can balance chemistry equations pretty nicely, because chemistry equations really are just the same as maths equations. Each molecule is essentially just a different variable in your like terms, etc. Another thing you can do, which is quite similar, is writing a compiler to interpret code or HTML. I know that many of you have already learnt HTML, but you can write a computer program to parse the grammar that is included in HTML. And HTML, like maths, has a strict grammar. You can also analyse the structure of written text for two purposes that I'm going to suggest. One is plagiarism detection, and the other is looking at the prejudices of historical authors. So plagiarism, suppose that, there are plagiarism pieces of software where you can upload, say, an essay to the internet, and it will tell you how plagiarised it is. Now, they aren't as simple as look for identical sentences, because obviously people know that all they need to do is get a sentence and change a few words here and there to synonyms, and suddenly, oh no, the plagiarism detector won't catch me anymore. But it will, because plagiarism detectors, not only do they look at vocabulary, but they can look at the grammar you've used. Grammar is implied by common words like the, and where you've put verbs, and so you can analyse the grammar of two essays, and if two essays or two paragraphs, let's say, have the same grammatical structure, it's quite include words with similar meaning, then it's pretty likely that they are plagiarised. Historical authors is really interesting. You could do this without grammar, actually, but nonetheless, it's still a field of linguistics. But you could go back and, let's say, grab a Shakespeare play or grab a number of Shakespeare texts and look for how many sentences there are that include a female word like girl or lady or a female name, and also include a word like week or, I don't know, let's just leave it at that. But, look for negative connotation words. And if you find that in his texts there's far more sentences that include female words and week, and then far more other sentences that include male words and strong adjectives. And you could either do this by hand, but more powerfully, you could write a program that would do that. Then you can pretty safely conclude that Shakespeare had an implicit prejudice that women were weak and men were strong. Now, you can do this for a whole bunch of authors, really, as long as their texts are available. And you can go to quite an amount of detail. You can also look at grammatical context to say, look at Shakespeare. Are his works grammatically complex or grammatically simple? Obviously, to do that, you would need to make sure that the grammar you use includes reference to Old English, and the grammar in Old English, I think, is a bit different to the grammar in modern English. I think it is more than just the vocabulary, but that's something you could research. And the fourth one, which is just something cool I thought of, you could encode hidden information in the grammar you use. So, for example, if I was telling a secret message to someone else, I could use completely nonsense made-up words, but put them in one particular grammatical structure, and that grammatical structure may itself contain a meaning. And so you could communicate to someone where your entire communication is based on what grammar is implied by the words you've used, and completely not based on the actual words you use. And that would be a really cool way of encoding hidden information that I think would just be fun. So, you could develop an encoding language and start talking to your friends while using words that have nothing to do with what you're actually communicating. That's a pretty, it'd be quite a complex thing to do, and you'd end up with a language that's probably more complex than Chinese, in the sense that all the unique characters in Chinese is part of the area the complexity comes from, and here you'd be doing a similar thing with whole grammatical structures. On a non-computational side, you could learn a fictitious language. Believe it or not, there are a large number of people who speak Sylvan, which is the language that elves in Lord of the Rings speak, or Vulcan is another one from Star Trek, or Dothraki, which is from the new drama series Game of Thrones, where they actually also invented a language purely for the purpose of that. Although Dothraki, it's interesting, they invented the language specifically to be pronounceable by the actors who they hired. So it's quite similar to, European type languages, because they knew that they wanted to hire actors with that sort of a language background. And that's, so if you've seen, so basically some languages lend themselves to different sounds, and so they had to make one that lent itself to the appropriate types of sounds. Whereas, some languages have weird characters that we aren't used to, like teeth tapping or that sound, which is in a fair number of languages. So there's extra characters which make differences. You could trace the evolution of languages by looking at the grammatical emergence over time, because obviously languages evolve through changes in vocabulary, but languages also evolve through changes in grammar, and the two together might be quite interesting. I mean, what happens when two groups of people speaking a different language live in the same vicinity? Obviously, they start borrowing each other's vocabulary, but I would be curious to see how their grammars evolve. Does one grammar sort of trump the other, or do they pick elements of both grammars, or do both grammars become acceptable? Maybe that's what happens. Maybe that's why English has so many different ways of saying the same thing, because they're kind of all just being adapted as as people speaking different languages come together. I guess that's similar to the next point, which is you can look at universals among languages, differences among languages. The final point, are there any grammar-free languages? Can you make a language where it's all about the words you choose and not at all about the order in which you place them? And also the final one, I guess, or the penultimate one, is language acquisition, which overlaps a lot if you're interested in making a children's book or something like that. But how do children learn language? What makes their first language so special about the grammatical structures, and their subsequent language more difficult, but based on brain formation and how they understand grammar?